Now we're going to look at the interpretation of the beta coefficients. Alright, but only the significant beta coefficients. An insignificant beta coefficient, alright, remember that beta hat 2 was found to be insignificant. An insignificant coefficient by definition is one that's too close to 0, and since it's too close to 0 we don't really know if this value that's represented as 0.3876 is 0 or a negative number or a very different positive number. So at that point we leave that one alone, and what we'll do is interpret only the significant x coefficients, beta coefficients, the beta hat 1 and the beta hat 0. Alright, what I'm going to do is to do them sort of backwards. Coefficient of x3 first, since it's a regular variable, and then the coefficient of x1 being a dummy variable, which are not as common for us as regular variables, regular quantitative variables. Alright, what I'm going to do is to show you a mechanism that will help most people get to the interpretations. If you can do this work in your head, that's fine, but all I want to see is the explanation of what these values mean. So what does the negative 0.1523 mean, and what does the negative 1.176 mean? Before we do that, we're going to do something which is similar to a total derivative. We use the capital Greek letter delta to mean a change. So a change in y is going to be equal to, we skip the intercept, minus 1.176 times the change in x1 plus, and we have to include the x2 variable because it is in the equation regardless of the fact that it's insignificant or not, minus 0.1523 times change in x3. Alright, so we're first, as I said before, we're going to look at the coefficient of x3, the value being negative 0.1523. In other words, we want a sentence that explains what the negative 0.1523 means from that regression. Alright, so mechanically what we're going to do first is to break out the negative 0.1523 from this equation. To do that, we'll have that delta x3 is plus 1, and delta x1 and delta x2 are both zeros. Okay, so what we'll have is that delta x3 becomes a 1, delta x2 is 0, delta x1 is 0, and what that'll do is to mean that that first term goes away, second term goes away, and delta x3 goes away, so what we're left with is that delta y is equal to a negative 0.1523. So we've separated out that particular number. So we'll let these things happen, then delta y is equal to the negative 0.1523. Before we can write a sentence to tell what this means, what we first have to understand is what we've done mechanically here. So delta x3 is plus 1. x3 was the age of this, x3 was the number of years of education of the senior citizen. So delta x3 means we're going to change the number of years of education of the senior citizen, and the other side, the plus 1, means by 1 year, right, 1 unit. So this is an increase in the years of education by 1 year. Delta x1 is 0 and delta x2 is 0, essentially means ceteris paribus, or all else constant. And by doing that, we've affected what essentially is a partial derivative, and then we're left with a change in y equal to a negative 0.1523. Y is the amount of TV watched per day, so there's a change in the amount of TV watched per day by this many units, and 1 unit of TV watch is 1 hour. So this is a decrease in the amount of TV watched by 0.1523 hours. Alright, so putting this together in a sentence, it goes as follows. It is estimated that each additional year of education will decrease the amount of TV watched per week, if you like, per day, I believe. Watched by 0.1523 hours. Alright, so it's estimated that each additional year of education will decrease because there's a minus sign on the coefficient, the amount of TV watched by that many units of the y variable, hours. Alright, so what we have here is, it is estimated that, which is essentially just trying to remind you that what we have in this regression is an estimate, it's not a fact. Alright, each additional year of education. Alright, that's basically the delta x3 is plus 1. We'll decrease the amount of TV watched by that many hours, and that's describing the delta y of negative 0.1523. Alright, so that's our first interpretation. Next interpretation will be for the dummy variable, the coefficient of x1, and the coefficient of x1 is a negative 1.176. Alright, need to handle this differently in a sense. What we really would like is also that the following, we let delta x1 be plus 1, and that delta x2 and delta x3, the other x's are unchanged, so the changes are 0. Alright, and what that'll do is to lead to a change in y equal to the value of the coefficient. Alright, all that's true, but one way of visualizing that is to think of a table here. Alright, so we'll have the values of x, and we'll do that for two hypothetical senior citizens. Alright, and like I said, what we want is to affect these particular changes, the delta x's. So what we want first is that delta x1 is plus 1. The only way to do that, since x1 is a dummy variable which can only have a 1 or 0 answer, is that first one is 0 and the second one is 1. Alright, so that means that senior citizen A is unmarried, right, since the dummy variable, this particular dummy variable is 0 if the senior citizen is unmarried, and senior citizen B is married, alright, since x1 is 1 for married. Alright, and then we want that the other two x's are unchanged, and so what we'll do here is just make up some values. Alright, so the age of senior citizen A, let's say 72 years old, then the other one has to be the same, and the number of years of education of senior citizen A, let's say 9 for B also, so it's unchanged. Alright, so what the output will be is that y star is, say, the whatever this result is for the number of hours of TV watched for an unmarried senior citizen, then the result for senior citizen B will be y star minus the 1.176 hours. Alright, so the amount of TV watched by a married senior citizen is 1.176 hours less than the number of hours of TV watched by a unmarried senior citizen. Alright, so we can write that down then. It is estimated that the amount of TV watched by a married senior citizen is 1.176 hours less than that watched by an unmarried senior citizen. Explanation of the negative 1.176, and that's the end of our interpretations, since we're not going to interpret the coefficient of x2, which is insignificant.